right, hi everybody. My name is Elise Rivera. I'm an MS student in the Shark Research and Conservation Lab, which is led by Dr. Catherine Macdonald. And my research aims to understand and increase our understanding of how sharks experience physiological stress. Another way to think about physiological stress is exercise-induced stress, and fish experience this when they resist capture on fishing gear. The effects of physiological stress can range from sublethal effects to things like at-vessel and post-release mortality. And measuring this and predicting this can be really difficult because it depends on things like environmental factors, life history traits, and fishing gear that you're using. What we do know is that tolerance really depends on species for sharks and rays. So we are most frequently going to be measuring this using lactate. This is a chemical that builds up in the blood as a shark resists that capture. And it's correlated with the time a shark spends on the line, as well as the amount of movement that it expends while it's on the line. This is also cool because we can measure it almost instantaneously in the field using the available tools to us. And we can see it over time from a range of just a few minutes if we take multiple blood samples from the same animal. A major limitation of this research, though, is that you have to have a shark on the boat to be able to take a blood sample, and so we don't know what's going on inside of that animal after it leaves us, right? And so that makes predicting things like post-release mortality much more difficult. My project aims to kind of understand what is happening as a shark recovers from physiological stress using the nurse shark, which is a species that is known to be very resilient to stress. We are combining methods, like I said already, lactate, and other chemicals in the blood that have only been studied in 2 other species called ACTH. We're also integrating accelerometry into this project so that we can see whether we can observe how much movement a shark is exhibiting on the line and see if that affects the lactate value. The most exciting thing I think that we're doing in this project is we're releasing the shark but still on the line so that we can go back to the same shark later in the day and take another blood sample up to several hours apart so that we can actually see how the lactate values are changing over the course of almost a full field day rather than just a few minutes that we would normally get in a normal capture. We're doing this so that we can better understand how fishing affects sharks. Unfortunately, a lot of the projects that we do here do induce stress on our sharks, and we wouldn't be able to learn the things that we do without catching them. But with this type of research, we can create research protocols that better protect the sharks while we have them on board. And this kind of information can also, and has also translated directly to fishing policies that better protect species that are especially vulnerable to fisheries capture. For instance, like prohibited species, quick release requirements, and things like that. So thank you. If you have questions, feel free to ask afterwards.